So we're at the north end, so the north end of Millook Haven. I like this bit because if you look up there, you can see we have some fantastic berms and storm bridges created by large waves during the winter and during the spring, where you have neap tides and spring tides throwing the material up to the back of the beach. One thing we need to mention at the start when we go on a field trip is you have to have a risk assessment, okay? And if you notice that me and Mr. Tyrrell are wearing our trainers, okay, because you don't want to go in flip-flops. I did actually think about wearing flip-flops this morning and then realised that that's silly because you bust your ankle, twist your ankle on these very steep ridges. But also if you look in the booklet, we have like one of the first activities is a risk assessment. So the nature of the hazard could be like twisting your ankle on the shingle ridges. Those are acceptable, anyone that's gone there really. The probability of it happening, low is 1, high to 10. It's not that high, but you could if you wear the wrong shoes. How severe is it? Well, you could break your ankle, so it's pretty severe. What could you do to reduce the risk? Where you'd wear sensible shoes. And then when you talk about all the different hazards, so you have getting caught by the tide, sunburn. Anything else, Mr. Tyrrell? What other ones?
Just on the travel to get to the location.
Yeah. Okay, so travelling, so you wear seat belts and all that sort of business on a minibus. Working in pairs.
Well,
stranger danger, yeah, working in pairs or in groups. And there's other ones that can be discussed too, but I think that's something to look at as well. Another area of our study as well is looking at the ethical considerations, and that's really, for example, taking pebbles home, and you shouldn't really, because that affects the dynamic equilibrium of the coastal system, so you don't do that. How you get here, it's better if you walk or cycle rather than going in a car individually, because that's the carbon footprint. Leaving rubbish is another ethical consideration. Making a noise and disrupting the local community or wildlife is another ethical consideration. Any others, Mr. Tyrrell?
It's just the social and environmental impact of your visit.
And that's very important. That's a key part on your project. Your project is split into 4 areas. And it's important that you discuss your ethical considerations in your conclusion. So you have your textbook theory, you have your methods, you have your results and your analysis of your results, and then you have your conclusions and your ethical considerations. There's different stages to your project, and we'll discuss that further down the line. The booklets we started with are information about our titles. So we have a study of the physical processes that influence the morphology of the beach at Millook Haven, okay? That's one idea. To test that, we're going to do a series of methods. We talked about angle, sediment, percolation, waves, the weather, maybe longshore drift, and any other ones that you can think of, looking at the textbooks, textbook theory. And then for each of those, they're a method, okay? And each method, you have to set up what's called hypotheses. And if you look at here, you can see there are different hypotheses. So the first hypothesis, you have a series of hypotheses for each, one for each of your methods really, okay? So for example, it's a statement that you prove or reject. It doesn't have to be right, it just has something you set up to test. So the beach profile will be steeper where sediment is larger, and that will probably refer to the sediment analysis we do in a minute. And that's one you could think of. You could think of another one. Percolation rates will be faster where sediment is larger. That's another one that you could think of. There's other ways of looking at it as well. Beach material will be larger in size at the back shore of the beach. That's another one. Beach material will be more rounded at the shoreline of the beach. So for each of your methods, and you can see here the different methods, angle, sediment, percolation, waves, weather, you need to have a hypothesis. And you'll go around in circles looking at that for a while, and then you'll talk to me and Mr. Tyrrell, and then you'll write an introduction in your project. We'll send it to the exam board, and they'll confirm that your hypotheses are correct, your title is correct, and it's all linked up. It's very much an inquiry, step by step. Okay, so what we're going to do now is show you how to actually do the studies and the different angle. We're going to do angle first, but we're going to do all of them in one go as we go up the beach, so you can see how it works. Okay, and if you have questions, you can ask us. So we're going to do what's like a transect up the beach. Okay, it's called a profile, and rather than just do it every 10 metres going up to the back of the beach, okay, that's not clear because you want to show the bumps, the angles all the way up to the back of the beach, so we do it every break of slope. So what that means is, so when it changes direction, we stop it there and we do the next measurement. So I'll start here at the water's edge. This is where the wave cut platform begins really, so this is like low water mark. And Mr. Tyrrell, where's your...
I'm looking for the first break of slope, so as I look up through that angle I can see that it kind of levels off a little bit here. So that's what I'm saying is my first break of slope.
So this is the first, so this is site A to site B, okay, and we're going to do this process and then we repeat it 4 days. You do the same thing for 4 times or 3 times so that you've got data to compare. So you measure the distance between me, which is site A, to Mr. Tyrrell, which is site B. So if you just get your... So, and if you look at striping, it's parallel, so you can get some sort of idea. So from there, that's how far is that, Mr. Tyrrell?
It is 2 metres and 7 centimetres.
Right, so we record that in our booklet. Site A to site B is 2 metres. How much?
2 metres 7 centimetres. 2.07.
Okay, that's the first break of slope, and then what I have to do is I get my clinometer. If you come a bit closer, you can see the clinometer, and what I do is I line it up there, that white bit there, to the white bit there Mr. Tyrrell was pointing to, yeah? And I shoot it like a gun. I line it up at the top of there, and I line it up, and I let it go, and if you look on here, it says read here. So that's 14 degrees. So you record it, site A to site B, 14 degrees. And then what we can do as well, at the same time,
Groups of 4 are ideal, so that you've got one pair measuring your angle and your distance, you're doing your beach profile, and you've got another pair doing your infiltration, percolation
and sediment.
measuring.
And sediment.
And sediment, yeah.
So what we do now, Mr. Tyrrell would stay there, okay, and I would move this to the next break of slope, which is probably here. And
So
then we
from
would
site
measure-
B to site C.
So site B to site C. Mr. Tyrrell would use the clinometer and do the angle again. We'd also measure the distance as well. Other way around. I'll just open
That's
that.
okay, that's okay.
So we're at 2 metres 40 between those two. Okay, you record that, so site B to site C is 2 metres 40. We then set up the angle again. Mr. Tyrrell,
And I'm looking at the beach profile, I'm thinking this looks like a shallower angle. I could be wrong, but that's my
and he's
just a
shooting
guess.
from my finger there.
And it's 13 degrees.
13 degrees.
So slightly different.
And then we repeat that process all the way up the beach, and we'll do that, and you can see it, and and you can get an idea, but we'll speed that up. But also, while we're doing this is the first one, this is looking at angle of slope, okay? But also at the break of slope, what we need to be doing, so if I go back to where we were at the beginning here, what you should have done as well is you look at the sediment, so you do a random grab of 10 pebbles, and we look at the power roundness scale, okay?
Oh, sorry, okay, 10, yeah, the
10
roundness.
pebbles.
Yeah.
So get 10 pebbles. 1, 2, 3, 4, 5.
That's 10.
Okay, and what you do, you measure the lie axis for each of those. You record them. Okay. You then take an average, but you could also work out the area if you wanted to make it really detailed. So you measure the angle up.
Long axes. It's 9.6 centimetres.
And you record that in your booklet, the angle of the number each pebble, work out the average.
Number 2, much smaller, 6.1 centimetres, and so on.
So that, and then you also look at the shape, using the power around the scale, and the power around the scale in the booklet.
So the power around this table goes from very angular to very rounded, and I've got to look at those 10 pebbles and make a decision on them. So when I look at pebble 1, that looks to me, that looks rounded, so that's, I would tick that column in my, or tally it. Number 2, quite rounded. Number 3, rounded. Number 4, very rounded. So you get the idea that the pebbles at the foreshore closest to the sea, they're really quite small and they're quite rounded in my sample here. That's kind of what I would expect to see, and then that might help me prove or disprove my hypothesis.
Also, it will create a flatter profile, whereas as you go further to the back of the beach, material should get more angular and bigger, and you can test that theory as well. Is that the case? And so you do a profile of the angle going up the beach. Okay. Another thing that we should be doing is percolation rate. So we get a volume of water, like a litre, for example, or half a litre. Don't get too much because you're forever going back to the beach to get more water. And you time how much the water runs through a certain amount of on the infiltrator. Okay, how much it runs through there. You put your pebbles in there, and then you tip water through it.
Pour your water through, time it on your phone, and record how long it takes. It's going to be very quick, but you would expect it to be longer here than you would as you go to the slightly larger sediment at the top of the beach.
And if you did do that five times, you take an average, okay, and you do that every time you do your clinometer reader. So one there, do one there, one there, one there, one there. So we've collected all the information as you go up the beach, okay? So we've done the angle, we've done the percolation rate, we've done the sediment analysis, okay? But also, what we also need to do, we look at the wave data as well. And if you look in your booklet, you'll be able to calculate whether the waves are constructive or destructive using the equation that I've placed in the back of there as well, okay? So you can work out whether the waves are constructive or destructive. As you can see today, really, they're low energy. You can look on a website for that, Magic Seaweed or Surf Forecast, to look at the kilojoules. You can look at the period of the waves as well, so you can record that as well to get an idea of whether the waves are constructive, destructive, and how that lends itself to creating the shape of the beach. Okay, and you do this process 3 or 4 times throughout the year, so that you can see the change. Somewhere like Millook Haven changes dramatically. So what me and Mr. Two are going to do now, we're going to continue to measure the angle up to the back of the beach. Okay, so you get the whole idea of how this works.
And at every stop, we're going to do the same process: pick 10 pebbles, decide on their roundness, do the percolation test, and the sediment measuring with the calipers at every stop.
So, looking at this, you see, back of the beach, large angular material. Some of it's come off the cliff. We also make a point of us adding that don't stand too close to the cliff. That's a health and safety issue as well. Be careful. You can see here, back of the beach,
Less well-rounded rocks.
they've been chucked up by storm probably, or they've been touched so much with the sea. Okay, and then you get down to the water's edge and you have them much more rounded and smaller, and they eventually erode through abrasion and form sand. Okay, but it depends how quickly it is, depends on the rock type, whether it's hard or soft, and and sort of the granular mix of it as well. Okay, so that's a bit of a demonstration about how to do coursework. Obviously it throws up loads of questions as well. I mean, doing the wave counts is something that if you look in your booklet it will show you how to do that as well. But what I wanted to show you really, well, because we can't go to the beach and do it ourselves, it's better that we can show you this and give you some sort of idea. Okay, so I'll set you some work based on this now. Alright, thank you for listening. Mr. Terry, got anything to say?
Remember to return the equipment, please.
Yeah, and don't break the tape measure, which is what we've managed to do every year. It just gets caught with the sand, doesn't it? Okay, thank you.
Thank you.